Stanford University.
Welcome, everyone. It's a pleasure to be with you on the third day of the 2018 Contemplation by Design Summit. We are having a variety of opportunities to learn. Yesterday, I hope some of you enjoyed the experiential opportunity of the Caroline concert. Tonight, we will have an experiential and more heart-based inspiration with Roshi Joan Halifax Memorial Church. And for this hour, we're going to understand the science of all of this experience that we are sharing together. It's a great pleasure to introduce Professor Manish Saggar, who's here in the Department of Psychiatry and Behavioral Science. And from his own personal practice of contemplation and meditation, he derives his wisdom that guides his research to help us to understand more fully how these practices are helping us through our whole body function as well as our spirit. So without further ado, let's welcome Professor Saggar.
Thank you so much for having me. I biked as fast as I could, and I'm a little bit catching my own breath. So maybe we should take a couple of deep breaths, all of us. Because there you go. Maybe a couple more. Thank you. So thanks so much for having me, Tia. Sorry again for the last second entrance. Today I'll talk about mostly about how meditation, how do we study meditation in using neuroscience tools, neuroimaging tools, and even genetics tools, and so on and so forth. So a brief background. By the way, I didn't realize this, but I don't know if you've seen these sculptures in Stanford Gardens by Rodin. One of them is called Meditation with Arms. And the other one is called Meditation Without Arms. Pretty interesting history behind it. Probably won't go today into it. But the outline for the talk, it's about 45 minutes or so. I'll talk about a brief background of myself and how I got into this field of meditation research. And then I'll go into the 4 major research themes that people are using these days to study contemplative neuroscience. And what do we mean by contemplative neuroscience to begin with? And because it's all a well-being setting, then how can we see meditation in the light of well-being, and how can it improve your well-being, and so on and so forth. And lastly, with remaining questions, and if we have some time at the end, love to give you something in addition to the blah blah. Maybe we can all meditate together for about 10 minutes or so, 15 minutes, whatever anybody likes. I will share a very simple meditation technique. Feel free to stop me at any time if you have any questions. Okay, so as I mentioned, my brief background, I started back in 2005 in University of Texas at Austin. And I was playing with these tiny Aibo robots. I don't know if you've seen them. They're really cute Sony robots. And our goal was to make a team which can beat their human soccer robot. Luckily, the aim was for 2050, so enough time for me to graduate. I was like, perfect. And then I got into the area of neural networks, also known as deep learning these days. And just like any other computer science graduate, we used to go to Google for summer internships, basically to play ping pong. But luckily for me, it was I also happened to attend a tech talk there by a monk who was giving a talk about a very interesting project that they were doing on meditation. It's called Shamatha project. You may have heard of it back in 2006 and 7, where they had people, about 60 or so volunteers, who meditated for about 5 hours a day on average, 6 hours a day for 3 months. And they wanted to see how that much intensive meditation practice changes anything from cognitive faculties to gene expressions all the way. And I was like, wow, that's what I want to do. Forget about the robotics. And I kind of sort of approached this monk and I said, can I take part in this awesome research? I know a little bit of programming. And he said, well, how much do you know about the brain and neuroscience? And I said, it's somewhat about here, but that's all I know. And he said, well, why don't you go back to school? He was very kind to me. And he said, take a couple more neuroscience courses and come back. And I did that. I took actually 9 neuroscience courses in my Ph.D. work. And then I, luckily enough, impressed him enough that he gave us me the data to play with. So we studied in this 3-month meditation retreat period when people meditated 6 hours a day every day. My job, my dissertation topic was how can I take the EEG data that they collected from these participants and see whether we can understand how the brain dynamics are changing. So not just see what meditation does to you, like improve cognitive faculties, help you with emotion regulation, but how does it do that? How does it do that particular part? That was my PhD work. And brain science, neuroscience being so fascinated, then I just couldn't go back to Google. Oh, by the way, this was the guy, Clifford Saron, who led this project, and you probably know the other guy on the right who's hugging him. And so that was my PhD work mostly. And then it's very hard, whenever you get a taste of neuroscience, it's kind of hard to go back to boring computer science, I think. So I came to psychiatry and then started my lab here last year. We are mostly studying neurodynamics, brain dynamics, and a variety of psychiatric disorders. Okay, so before I begin with meditation and its results, many people have asked me, people who don't meditate particularly, that it's probably just another hype. So somebody mentioned to me, if you look at Time magazine, every 10 to 15 years they have a cover on meditation. And then we forget about it, then it pops up again. And then we forget about it. So this is probably just another hype and it'll go away. And because we live in Silicon Valley, I looked up what the hell is hype cycle exactly. And apparently it's something like this. So when a technology comes in, we are very excited about it. And then we realize, oh my God, it's not that awesome. And then we're somewhere here. And then it takes a while for us to then go back and really use it. So if you're a Bitcoin fan, you're probably somewhere here right now. Maybe. And so I said, okay, how can we see whether this is the case for meditation? So the easiest thing for a researcher to do is you go to PubMed, a website, which indexes all kind of journals, all kind of publications on meditation across all peer-reviewed journals. And then I just am plotting here over the years how many papers are published which have a keyword or entitle the word meditation and it's some kind of effects. And if you see here, there was a blip here back in the 70s, and then we are like, this is probably the hype cycle, I'm guessing. And there was a plateau, and then we finally realized the optimal use of meditation. It's no more a hype anymore. So last year alone, there were close to 400 publications. And as much as you know research, publications usually happen with no null findings. So most of them are positive findings. They found some effect of meditation and how it improves certain aspects of life. So if anybody tells you meditation is probably a hype, tell them no. We can go and check it out on PubMed. But the other thing with meditation, some of the other questions that are being asked is that, well, meditation is so complex. If you actually go to any meditation guru or a yogi, they will not give you a one-line answer for what meditation is probably, because it's so complex, it's full of all kinds of amazing spiritual, religious backgrounds. Then how in the world can science possibly study that? We don't have the tools to go there yet. So back in the graduate school, that was my question to myself, and my PhD advisors kind of pushed me to look into the commonality between all kinds of meditation techniques that are out there and try to find out exactly what it is that we can possibly study. Of course, I'm not the only one who did that. Many people have done it before to figure out, irrespective of which meditation practice you do, what is the most common thing? What is the most basic, common, minimal denominator we can find across all meditation practices, so we can at least start there. And apart from sitting on your butt, there's something else, right, that we all do, hopefully, in meditation. And the thing that popped up was this idea of cognitive control. In other words, following the instructions, right? So no matter which meditation technique you're practicing, the first thing you have to do is follow the instructions. If the instruction is something like, close your eyes, then you close your eyes. And it says, think of nothing, which is impossible. Or some other task, focus on your breath. Then all you have to do is stay on the breath, and if attention invariably lapses, you bring it back. It lapses, you bring it back. And in psychology or neuroscience framework, cognitive control pretty much captures that very nicely. So the idea is when you see that stop sign, hopefully all of you stop and not do the California roll, but at least you slow down, right? And that kind of inhibition that we exercise on our obvious actions is what cognitive control is all about. So ability to flexibly guide behavior in accordance with some kind of internal representation and goals. And overcoming otherwise compelling response tendencies. For example, if I'm giving a talk right now and I know so many people are watching me, I'm probably getting video recorded, and if I really want to itch, I just can't. Evolutionarily, I'm supposed to do it because it's like built into my system and body, but I am resisting that. And I'm exercising my cognitive control. And we do that all the time throughout our lives. So if we take the lens of cognitive control, and then you go through all kinds of meditation exercises, it becomes So I'm not saying cognitive control is the center of everything, but it is a main idea behind all kinds of meditation, but it's a very central theme no matter which meditation we pick up. And if you take that as a lens to study meditation, things get much easier and simpler from the scientific perspective. Does that make some sense? Yeah. Actually, there was a very nice analogy. I was recently reading a book by Matthew Ricard and Wolf Singer, and he talks about in a very different way about cognitive control. And he says in his book, think of the mind as a torch or a torchlight, right? And you're shining the torchlight on different things. So it's not that, so you can shine the torchlight on a pile of garbage, and you can also shine the torchlight on a pile of gold, perhaps. But wherever you shine, that's where your attention will kind of sort of go. So it's not that the mind is so-called a bad thing, or it's more that if you have the control over the torchlight. Does that make some sense? It was a very interesting analogy to me. So if we get the control back of the torchlight, or the flashlight, whatever we call in the US, that might really be the main key behind all meditation practices. Okay, so a quick demo of cognitive control. So might as well collect some data here. If you quickly read these words, it's very easy. So blue, brown, white, red, orange, purple, pink, green, black, gray. Not too difficult. Now I tell you to read the word but not the color. Hopefully you'll slow down and make more errors. It's a very common cognitive control demo called Stroop task. And now instead of asking to name the word, to read the word, I ask you to name the color itself. So green, and then purple, and then yellow, and then red, and so on and so forth. So you're slowing down, right? And you're probably making more errors. So the idea with cognitive control, but you can still do the task, hopefully. And the idea is that irrespective of how many distractions are there, we can still perform the task. And that's basically what cognitive control is. And it very nicely blends into meditation. So let me give you a quick, sort of like a very, very, probably very stupid and naive view. But if you're told to do any kind of meditation instruction, few minutes later, that's almost always happens to me when I do it at night, I go into this thing called sleepitation, right? I'm like nodding, and my wife is like, what is it doing? But it's not meditation at all. You're basically tired, might as well go to sleep. And if I do it in the morning, I get bombarded by a bunch of thoughts. And if you have ever experienced meditation, perhaps you're a very long-term practitioner, but most of the people who start meditation, that's a huge problem. We just get reminded of all kinds of things, sometimes really amazing ideas. It's like, oh my God, let me just write it down. And then you don't meditate anymore, of course. And what happens is with practice, several thousand hours of practice in some cases, some of the Buddhist monks that neuroscientists have studied have close to 27 to 44,000 hours of meditation. That's a lot of math. And I was just actually doing that. So I thought yesterday, I was like, okay, if I have to get 44,000 hours of meditation, how many years do I need to meditate? Turns out 30 years, 3 hours a day. I was like, no, never mind. Maybe next life. Okay, but the interesting thing is that if I just replace the meditation instructions with like studying a boring IEEE article, basically the same things happen to me. I again go into this research mode. That was from a t-shirt my wife gave me finally. Or we go into this mind-wandering state. And of course, by repetition or coffee, one of those, we tend to go back to the study, right? And the idea, again, is repetition. So it's not like we are born to read IEEE articles. We really slug through it. We have to, learn too much to then finally understand these things. Or any kind of study material you can pick. So if you take this idea of you're trying to focus on something, and your attention invariably lapses, and you bring it back, and then it lapses again, and then you gently bring it back. This we do no matter what we do in life. So if you're studying, if you're talking to your spouse, perhaps right now when you're listening to me, your mind will wander into probably lunch, and then it'll come back, and you're like, oh my God, it's still talking. And then you go again, and you come back. So this will happen no matter what. And this kind of mind wanderings can be very useful at times as well. But if you have some kind of cognitive control over them, you can really enhance your productivity. And that's exactly what meditation teaches. So if you take meditation as a mental health and just keep cognitive control as a so-called mental analogous to a mental muscle that you need to exercise, When we exercise this muscle every time when we meditate, we make it stronger and stronger and stronger, so that when you're talking to your spouse, you're actually talking to your spouse, and not anywhere else, right? Or whatever else you're doing, you're actually there. Does that make sense? It's a very simplified view, but it actually helped a lot in terms of doing the literature survey for me and understanding how meditation does what it does. Okay, so now with this background, going to contemplative neuroscience. It's a relatively new name. I think Alan Wallace was considered the person who coined this term, and that's the guy who actually I met at Google, Alan Wallace. He was a Buddhist monk. And the idea behind this term is that it's a research field where you basically study meditation practices using tools from all kinds of space, all kinds of science, neuroimaging, different kind of ways to looking at the brain activity, fMRI, EEG, so on and so forth, epigenetic research, and also behavioral research. And more or less, they are divided into these 4 different themes that Richie Davidson talks about. One of them is neuroplasticity, the idea where we basically understand brain as a device or an organ which is built to change with experience. That's all what neuroplasticity is all about. And we want to see how we can change the brain in case of meditation practices to make it more optimal in some way. Yeah? So that's what all the research on neuroplasticity is about. And then epigenetic is pretty much similar concept to brain, is how can we then regulate the genes by experience and so on and so forth. So again, researchers wanted to see how contemplative practices, especially intensive meditation practices, how can they have an effect on gene expressions. And I'll actually share a couple of studies for each one of them in a bit. The third one is more brain and body interaction, and that's very interesting when we talk about meditation and neuroscience of meditation. Almost always we focus on the brain. Very rarely we pay any attention to the body. But it's changing now. More and more people are looking at the interaction between the two. It's a very funny example about, I think back in 1992, Richie Davidson and Clifford Saron, my Ph.D. advisor, had a chance to go to Dharamshala in India to look at some of the brain activity in some of the monks. And he told me this story. He said when they went there and they told the monks asked them, what exactly are you trying to do? And they said, we're trying to measure some way of measuring how you are able to regulate your emotions. And that suddenly they all started laughing. And they didn't really know why they were laughing. So they asked them, what happened? Did we tell you a joke or something? And they said, well, if you want to measure emotion, why are you putting a cap here? Why don't you put it here? And so that was very profound, I think, experience for something to think about. And now finally we are getting to that point, probably around 30 years later. And so the idea is that if you think about psychological stress, for example, and we now have plenty of evidence to suggest that psychological stress or any kind of chronic stress have trickle-down effects on all parts of your body, and including all the way down to gut microbiome and even the inflammation there. And so how does that happen? It's not like your gut has its own sensors which is reading the environment, right? It's going through the brain, what we perceive, the perceived stress. So the idea is that if we perceive stress and it affects the body negatively, can we somehow perceive the environment in a positive way so we can have a positive effect on the body, basically. And there are a couple of studies done to show that link. And the last one is a bit more controversial, and the idea there is, some part of it is controversial. The main idea is behavioral changes, that when we meditate a lot, we have a better handle on our cognitive faculties, like attention and emotion regulation. But some of the researchers also think that it's not that we are getting better at these things when we meditate. The idea there is more that we are born with a lot of goodness in us, and we're just peeling the crappy layers on top of us, which we gain throughout the life. So that's the debate there, is whether we are innately good or whether we become good. Either way, we become good at the end, so it's fine. But there was very interesting research done to show how babies, when they are infants in the early 6 months, how they portray altruistic behavior very beautifully. And I'll share some of that as well. Any questions? I think good. Great. So hopefully your mind wandering is going well. Okay, neuroplasticity. So let's start with this study. It was published back in 2013. Antoine Lutz was the first author in Richie Davidson's lab. And in this study, they particularly were interested in how the anticipation of a pain stimulus and the habituation to a pain stimulus is different in people who are long-term meditators, and they are really long-term meditators. These are the people with average 27,000 hours of meditation in their life, and they wanted to see if you have this one trial where you meditate for like 45 seconds or so, and then they give you a thermal stimulus on your hand, while, by the way, you're lying down in the scanner. It's a pretty crazy experiment. And you can either get a warm stimulus, and then you may or may not get the hot stimulus after it. So the second you get the warm, you're anticipating, now I'm going to get the hot stimuli, and it's going to inflict the pain, and then it disappears. The pain intensity is pretty high usually, so even though, thankfully, there are no long-term effects of this torture, but it's a very interesting experiment to measure the pain intensity and unpleasantness. And they showed, first of all, behaviorally, that if you have novices in the blue and experts in the red, the intensity measure is pretty same, so they both say 7 on the scale, pain scale or something. But the unpleasantness is way down in case of experts, so they're not much distressed or don't feel it much of an unpleasant effect afterwards. Now somebody could say, well, they're probably faking it, who knows? What if we actually look at the brain signals in this case? So this is fMRI data from anterior insula, and I'm sorry, it's a lot of a lot of lines there. But so A1 is the right after the meditation period or during the meditation period. A2 is when they are anticipating the signal. A3 is when they actually get the signal. So in the green and the novices, green and novice blue are the lines. W means when they got just a warm and no heat signal, and H means when they actually got the intense pain signal. So if we look at the top two lines, the blue and green, novices pretty much were all the way up there, anticipating, activating this area of the brain which is measures the interoceptive signals, and having a huge, perhaps the unpleasant response due to which. But if you look at the experienced meditators, in the case of W, is very interesting. W means just the warm, no heat. The yellow line, it basically just flats out. Even so, there is no, and unless there is a pain stimuli, they don't react. But if you look at novices, they react no matter what. And if you further look at the after A3 period, that's where the residual response is. So meaning the pain is gone now, and meditators go back right after it, the red line, but the novices pretty much stay up there. So it's like somebody cut you in traffic in the morning, and you're pissed off all day. Something like that. Meaning we don't just go back to normal right away. And that has been shown in another study, in the Shamatha project that I talked about as well. I don't have the slides here, but they showed that when a bunch of meditators were shown during this intensive meditation practice where they meditated 6 hours every day for 3 months, at the end of this meditation experience, as compared to the before, when they began, when we showed them movies where there was a lot of disgusting stimuli, they would, in the beginning, they would stay mad, we recorded their facial expressions in a hidden camera, so we knew what we did, something called a fax encoding to know what kind of emotion they're representing. So the disgust and anger was kind of stayed there even after the movie was over 10 minutes later. But if you looked at their same responses with different movies, equal intensity though, after 3 months of meditation, they would get, again, same anger level, disgust level, but they would come back right after the movie ended. So that's very interesting. So that's like by design, and I would say we have built up crap on top of it, which makes us anticipate these negative stimuli much more strongly and also have a much more stronger residual effect. Yeah?
I'm wondering, does it also relate to how pain is inevitable and suffering?
Yeah, I guess, yeah. So the question was related to pain is inevitable and suffering is optional. I would say so, yeah. Absolutely. And then they also correlated this response, this difference, with the hours of meditation. And initially I was like, 45 hours, no big deal. But then I saw the scale is 10 to the power 3. Never mind. But the idea is that we can all reach there. Maybe even if you reached at 25, it's probably good enough. But very interesting results. Another results comes from brain morphometry, meaning looking at the hardware change in the brain. This was more of software, the pain one. Hardware meaning we look at the neocortex, the thickness of the neocortex, and we know that as we age, the cortex. Well, before I go there, as you can see, I didn't practice my slides. Some of the regions that we know are engaged when we meditate are also activated when we exercise cognitive control. So if the task we just did, where we were looking at these words, and I tell you change, not read the word, not the color, read the color, not the word kind of thing. When you exercise cognitive control, and if you put you in an fMRI scanner, we see similar regions that are activated when you're actually trying to meditate, which makes sense because you're regulating your attention in both cases. So we find prefrontal regions to be activated. We find insula to be activated when people meditate inside some kind of neuroimaging device. So the question that some of the colleagues from MGH asked is that if people are meditating for a long, long time, 45,000 hours or so, then shouldn't there also be a structural change, meaning should the neocortex be any different in these particular regions because of that much meditation experience? And they looked at it, and it was published back in 2005 with Sarah Lazar, where this was more of a cross-sectional study, meaning it's not that they followed a guy from 20 years to 55, which will take forever, but instead they took people at different age groups, and they kept a much less stringent criteria than 44,000 hours. They had more like 40 minutes a day meditation minimum for at least, I think, 3 years or so in the back. And they wanted to see if you have these people and you look at the regions which are known to be engaged in cognitive control, then whether the cortical thinning is somewhat different. So as I was mentioning earlier, as we age, our cortical neocortex, the thin layer around the brain, thins over time as we age. So it starts about close to 2.53 millimeter and goes all the way down, further down as we go to 70 or 80, probably closer to 1.5 to less than 1 millimeter. And they wanted to see whether people who meditate, perhaps that is slowed down or at least somewhat stable. And that's exactly what they found. So red color squares are people who never meditated in their life. And the blue circles are the people who have been meditating at least 40 minutes a day for the last 3 years or more. And they found this very interesting result. And it has been replicated since 2005 study that these areas which are engaged in this cognitive control, the thinning was slowed down at the very least, if not stopped. Yeah.
What is the effect of the thinning normally? Does it slow down your thinking, or?
So basically, the neocortex is the region of the brain which has all the neurons, all the neural computation is there. So everything goes with thinning. Wisdom remains. Just kidding. I don't know. But you need for learning, for planning, for any abstract thinking, creative thinking, intelligence, you need all these regions, absolutely. So look where you are in the age group and start meditating today. Okay, so the other piece of, I don't know why I'm focusing on aging today, but the other piece of literature comes from the idea that when these meditators, long-term meditators, they have some way of slowing down the aging. There's an old saying in the East. When I was growing up, my mom used to say, oh, these meditators go to Himalayas and they meditate for thousands of years. And I was like, what? How is that even possible? But I'm not saying we found the way to live for thousands of years. But the idea is that one of the hypotheses was that when you meditate, you can slow down the aging process. And in the Shamatha project, we wanted to see whether Clifford Saron and his colleagues wanted to see whether we can actually show quantifiably whether the aging process is slowed. And one of the markers of that is telomere in your gene expression. It's like a zipper in your jacket. And if it shrinks in length as we age, and they wanted to see whether that shrinking has slowed down in some way. So this was Shamatha data published in 2011 in Neuropsychopharmacology. This is the group where people were meditating 6 hours every day for 3 months. And we found that, so this is a different way of showing it, but we found that in the group who meditated for this much time, they were able to slow down the telomere reduction, and it was positively associated with psychological well-being. So another good indicator of how meditation can work, both at the mental level as well as the gene expression level. Okay, so this is an example of the brain-body interaction. This was published back in 2003 in Psychosomatic Medicine. And this was a very interesting study in the sense that they wanted to see that, to convince people like you and I who are probably not going to go to Himalaya and meditate for 44,000 hours, if we just do a much shorter intervention of like 8 weeks, or so, and we meditate like 40 minutes a day or something like that, or 20 minutes a day, can we still see some effects? So they actually did this study in Wisconsin, Madison, Wisconsin, in Richie Davidson's group again, where they went to corporate setting, and people meditated there for 8 weeks. Like people who had regular jobs, they meditated for like 20 minutes or 40 minutes a day for 8 weeks. And they wanted to see at the end of the 8 weeks, if we give you a flu shot as compared to a control group who also gets a flu shot at the end of some control training or wait list and at the end of the 8 weeks, which flu shot gets a better impact, so to speak. So they measured this thing called, I actually don't remember the name, antibody titers to influenza vaccine, and they found people who meditated just 8 weeks, they had significantly more antibody rise from 3 to 5 weeks to 8 to 9 post-vaccine. So this is 9 weeks post the vaccine, 8 to 9 weeks, and they were given vaccine for about 3 to 5 weeks after the intervention. So another interesting result. Of course, all these results that I'm showing you, they are getting replicated, and they need to be more replicated for much more stronger, significant results. These are more like proof of concepts at this stage, but we are collecting more and more evidence, all in the same direction, that meditation has a positive influence. But irrespective, like on a personal level, I have realized that all these interesting results boils down to blah blah if I don't meditate every day. And that's why I want, at the end of the talk today, would like to have you meditate a little bit at least. And you will meditation is what it does to you, and you have a personal experience about how it's changing your life. You don't necessarily need 20 science papers to tell you, yeah, it's working, and then you'll go meditate. But perhaps that will motivate enough that you will start at least. Fluid intelligence, this is again Sarah Lazar's group, much more recent paper published in 2015. Just like they did the experiment with cortical thinning, here they're looking at fluid intelligence, so the ability of the part of intelligence which is changeable in nature, trainable in nature. So for example, learning more, enhancing vocabulary, or remembering more items in a working memory, or better information processing, you can respond faster. And they found that these variables of fluid intelligence in general and regular controls kind of sort of decline, just like our cortical thinning happens. Our ability to have higher fluid intelligence drops with aging. And then they compared two groups there, three groups, controls, yogis, and meditators. And they found actually the people who are yogis, so these are people who are meditating plus doing yoga, they had the best result. They basically slowed down and stayed fluid, had more intelligence across the age span. Meditators were slightly less, but better than controls, and controls had a normal aging process. Yeah?
Can you say a word about, for a result like this, how do they control for the other factors that would be correlated for being a yogi or choosing to meditate?
No, absolutely. So it's always a hard problem when you're looking at meditation data. So most of this data is correlational in nature. You have to have plenty of replication to truly study it. And that's why I was saying all these things are something that you have to experience yourself to really, really understand. There are plenty of factors. For example, when we did the Shamatha project, many people said, so this was a project where people flew to Colorado, Boulder, stayed there for 3 months, and people said, what if all you're seeing is they were not using Wi-Fi or Google phone or whatever. Maybe that's all it is. Maybe there is no meditation. In fact, if you show people that, look, it correlates with how many hours of meditation you do, then people say, what if it's just an effect of sitting on your butt? Well, yes, that's possible. But again, it's something that you really have to try yourself and see. But great questions. Okay, innate goodness. And this is a very cool video. I don't know if you can lower the lights just for this one. Here?
In this study, parents bring their 6-month-olds into the lab.
At the other side of a long table is a hill stage. A red circle guy with googly eyes tries to climb the hill. He sort of goes up the hill and then falls back down. He always fails at it. Then a blue square character, also with googly eyes, comes from the bottom of the hill and bumps him up to the top of the hill so that he's successful. On different trials, the climber tries again to get to the top of the hill, and then a yellow triangle character comes down from the top and bumps him to the bottom of the hill, so prevents him from getting his goal. Babies see this a number of times until they get nice and bored with it. So we stop and basically do a choice measure. The moms are asked to close their eyes. An experimenter who did not see which character was which brings over the two characters to the babies and just sees which character the baby touches first.
Which one do you want?
We found that, impressively actually, almost 100% of babies preferred the more positive character.
What do you want?
Okay.
They seem to have an attraction to helpful, pro-social individuals and also a real aversion to antisocial, unhelpful individuals.
Okay. So again, very preliminary evidence, but good news is we're no fault in manufacturing. We're all born perfectly well. Perhaps we learned the gunk over time and we can work on it. That was just, again, a very preliminary evidence, proof of concept, and more research is being done to see whether if you introduce meditation much earlier, during pre-K curriculum, for example, does that have an impact? You may have heard of this study where they had this delay in gratification study done in young kids and how they were much more successful 30 years down the road. So similar studies are being underway which convince that if you invest meditation-like trainings in much earlier age, then can they have a much better impact on their lives, kids' lives, so on and so forth. Because imagine 44,000 hours, you got to start early. Okay, so going back to well-being, just want to show you some of the studies, especially related to a couple of concepts. One of them is mind wandering. And as I mentioned, mind wandering is something that happens invariably, no matter how hard we try for it not to happen. It'll just, our attention lapses into something, and lo and behold, we realize, oh, that's not what I want to do, and you come back. And of course, the different medias and apps takes us there, no matter what we do. But so just to define mind wandering very, very scientifically, we have a person who's trying to work, but he's thinking of the movie. That's mind wandering. Person trying to work, thinking of probably a vacation, mind wandering, and the guy is probably not mind wandering because he's focused on his work. And they wanted to see, one of the studies done in Harvard, and was published in one of the best journals we have, Science. They wanted to see whether such mind wanderings makes you happy or unhappy. You may have heard about this very interesting study. And the idea was, well, maybe when you're thinking of something negative, that'll make you unhappy. But what if you think of something positive? By think, I mean when your mind wanders and you're thinking of something positive, like a vacation at the end of the year, shouldn't that make you happier? And that's what they wanted to study. So they wanted to compare mind wandering neutral, meaning like, I don't know, thinking about what you're going to eat, versus mind wandering positive, a vacation, versus mind wandering negative, where you're thinking about something happened in the past that you hated, and you kind of ruminate on that. So to do that, and this was published in Science, there's a beautiful TED Talk, by the way, that you should check out by Matthew. And this is how they tested it, by giving volunteers an app which pops up on their phone about 3 to 7 times, I think, during a day, or 6 to 7 times. And it has 3 screens, basically. The first thing pops up says how happy you are, or how sad, and you can say very sad to very happy. And it'll ask you, what are you doing? So you could say commuting, washing dishes, whatever, you can check box. And then it'll say, were you thinking of anything other than what you were doing? So you can say, no, I was very focused. Or you can say yes, positive mind wandering, yes, negative mind wandering, or you can say neutral mind wandering, right? Very simple way of collecting data. And they collected data over really high number of people, 650,000 real-time reports, over 15,000 people in the study, across countries and occupation and marital status and income and socioeconomic status. And they wanted to see whether this happiness changes. By the way, interesting fact, in the United States alone, they had this measure that was published in 2010. They said about 47% of the time, US adults have mind wandering state. That's a lot of mind wandering, we all do. And just to explain again, mind wandering doesn't mean that you're doing some kind of creative thinking, like you're like trying to solve a problem and you're like, oh, let me just go for a walk. That's not necessarily what mind wandering is. There your goal is to find a solution to the problem creatively. Mind wandering is where you're trying to do one thing, you just can't do it, you just mind wanders. You're trying to do one thing, it wanders again, and you bring it back. That's what mind wandering is, where you don't have that cognitive control and it just slips away. And they saw that if you look at presently focused people who were doing the dishes when they're focused on the dishes, they were the happiest apparently. If you look at mind-wandering pleasant, even that was slightly less and apparently significant happiness level than mind-wandering neutral or negative. So even when you are thinking of a vacation or something positive and your mind wanders into those states of positive, even then your happiness level was less as when you're actually focused on the task. So that's a very interesting result, I think, and something to think about. And imagine what helps you with mind wandering or having reduced mind wandering is meditation. The same principle, when you meditate, when anybody meditates, you try to follow the instructions, your mind tries to wander, you bring it back. It wanders, you bring it back. So you strengthen this muscle of cognitive control that automatically helps you with reducing the amount of mind wandering. And when you want to mind wander, then it becomes your task, then you can do it if you want. But you have the control. You are in charge and not driven by your emotions, experiences, or news cycles, which we are very fond of these days. The other scientific example, or other thing I want to focus on, is the effect of chronic stress. So these are the pictures of first day, first term, first day, second term, so on and so forth. I don't know what happened this time. And so about 20 years ago, right? So there was communicable diseases was a big issue, and now when we talk to healthcare people who are looking at the financial burden that healthcare is going to have in the United States, it's much more focused on non-communicable disorders, which are born out of stress, mostly psychological stress. And that could be cardiovascular diseases, blood pressure, diabetes, respiratory issues, also psychiatric issues. And because healthcare is so cheap in US, that's a joke. Because it's not cheap, we really, I was checking whether how many of you are mind wandering. It's very, very important to take that perspective into account as well. And studies that I'm about to show you, where they wanted to see whether meditation training will reduce the number of ER visits, emergency room visits, in people who have much frequent visiting habit, or they had to go to ER much more frequently. If you give them meditation training, would that reduce their billable encounter, so to speak, meaning the insurance, the money that we spent on healthcare. And that would, if the idea was when we show something like that, perhaps that will also push a lot of people towards meditation, because you can reduce the healthcare burden in general. So this study was done back in, I think, 2014. I missed the year, my mistake. By Stahl and all, and they wanted to see, so sorry, there are too many lines on this chart, but focus only on the top two. So on the y-axis are billable encounters by these people. So they took people, on purpose, they took a population of people who have more than 60 visits, I think, to ER every year. So very, very frequent ER visitors. And they wanted to then give them two interventions. One of them is mindfulness-based stress reduction, some kind of meditation intervention. Another one is another, I think, health intervention, to see whether there is any effect on reducing the number of billable encounters. And that was indeed what they found 1 year later, that the number of visits went down much more highly in people who got the meditation intervention. It was like 20 minutes a day kind of meditation training, so much more lighter kind of sort of training than otherwise. So if healthcare burden is, you think it's an issue and you would like to reduce the burden, go meditate, I guess. Another way of motivating you to meditate. Okay, I think last one is a pretty nice paper by Clifford Nass and Anthony Wagner and Ophir back in, I think, 2003, if I'm not wrong, in PNAS, Proceedings of National Academy of Sciences, where they wanted to see, let me backtrack a little bit. Whenever we talk about meditation and focusing our attention and doing enhancing cognitive control, people say, oh, but what about multitasking? That's like the first question I sometimes get. Is multitasking okay? And this was a beautiful paper to show multitasking is not okay, apparently. It's actually can have a much more detrimental effect than not. So for this example, Cliff and others, what the experiment they did was they would show you this plus sign for 200 milliseconds, then you will just see these bars, right? Some boxes, I hope you can see them in the back. They're red bars and blue bars. And there are way more blue bars than red bars. There are 2 red bars and like 5 or 6 or 7 blue bars. And you can increase the number of blue bars. And the blue bars are called distractors. So you don't tell that to the participants, you just tell them, look, just focus on the red bars, forget about everything else. Yeah, you tell them there are 2 bars, just focus on them, don't worry about anything else. And then a few seconds later, you tell them the only thing they have to do is when they're looking at the red bars, if the red bar rotate or move in position, you just say yes versus no, right? Very simple task. So even though there are other distractors, you just focus on the red bars, and if they move, you press the button. So very straightforward, simple task. And the idea that was to kind of sort of demyth that multitaskers are better at this handling distraction and stuff like that. And they showed actually that high multitaskers, actually their performance tumbles down when you just simply increase the blue bars. So even if you tell them don't worry about the blue bars, just focus on the red bars, people who, HMM actually means high media multitaskers. So people like us who have a phone, an iPad, and a laptop and a desktop all on, and we're getting Slack notifications and Facebook notifications, and we think we're doing amazing work by multitasking gazillion ways. They ended up showing they have the worst cognitive control as compared to light media workers. Same is true with other cognitive performance, like 2-back and 3-back are memory tasks. They perform pretty poorly on that. So high number means you're more false alarm rate, meaning you're a poor performer, and you're also slower than people who are light multitaskers. And again, how do you learn not to multitask? I'll bring it back to, again, meditation. If you think about it, if you talk to somebody, if you know who's a multitasker, perhaps you have your own experience, people sometimes just get bored with one thing, and they want to go to the next thing or something else. To stay excited, to stay stimulated, we bombard ourselves with all kinds of subscriptions, so to speak, and that's how sometimes multitasking happens. And I was talking to, I think, a monk and I was asking them, why do you guys, focusing on the breath is some of the most simplest things. Why did you guys decide the breath and not something else? Maybe, I don't know. And they said that's the most boring thing. And if you can learn to focus on that, you can learn to focus on anything in the world. And that makes a lot of sense. So when we meditate, we enhance this cognitive control. When we learn to focus on something which is probably not very much stimulating, then you can transfer that learning to anything and everything you do in life. So if you take out all the beautiful spiritual, religious aspects of meditation and just focus on mental health and well-being, that alone should be a very good motivator to push you towards trying meditation if you haven't done it, and do it regularly and not just once in a while. Okay, so some of the remaining questions, and how much time do I have left? 10 minutes? Okay, so I'll go through them very quickly so we can actually meditate. I don't know why I chose to do capital, but how meditation does what it does is still kind of sort of more of a mystery. So some of the work I did back in Ph.D. was to look at dynamical systems. So we try to simulate brain activity while meditation using some computational models. And we were able to show in this computational space that meditation is enhancing stability in the brain. But much more work is needed to actually learn the basics of how exactly meditation helps with better cognitive control. Like, intuitively it makes sense, but most of the basic research is still upcoming. And then there is another new area of research which is coming out of this innate goodness piece, is that does meditation makes us more ethical? And there is a lot of research going on, especially Richie's lab, to take a look at that. The third piece is whether can we do meditation. So most of the meditation research I mentioned here was done at a smaller scales anyways. So like 50, 100 people. Can we do it at much larger scales? Or you may have heard of Human Genome Project or Human Connectome Project. They were done at much larger scales. Can we do the similar things in meditation to look at much more larger populations to see the interventions help? Another interesting idea, I think, that somebody asked Richie Davidson was, can we also have a brain bank for meditators? So long-term meditators, can we take their brains after they pass away peacefully, hopefully, to then look at their brains and so on and so forth. I've been feeling great, so I will slow down. And then meditation in pre-K and young children, as I mentioned again. And the last one is, how can we use meditation interventions for psychiatric disorders? So most of this work is ongoing, but it's not I remember back in 2008 when I went for a Mind and Life Research Institute summer workshop. That's a very nice workshop where all the scientists who are working on meditation get together in, I think, New York somewhere. One of the scientists there said that when he was studying meditation, they had to be some kind of double agent, meaning they would be doing some research on meditation, but saying, oh, we are actually studying emotional regulation, and not really use the word meditation. Because the second they use the word meditation, the funding kind of sort of dried out. But that's changing much more now. Much more rigorous science is getting into this area. And as you can saw with the number of publications being published every year. So hopefully that change is happening. So if you're looking to do research in this area, I would highly, highly recommend. This is a great time to get into. Okay, if no more, yeah.
Contraindications. I heard there are also contraindications for meditation, for example, psychiatric disorders.
Contraindications. Can you elaborate more on that?
So, for example, people with high anxiety or sometimes
should not meditate?
sorry?
Are you saying they should not meditate?
Yeah, sometimes it can trigger things.
Oh, I see what you mean. So yeah, so of course, in the side effects. There are no, as far as I know, there are no known negative effects of meditation. In PubMed, I've searched very deeply for that.
I saw articles about creating something like psychosis or something like that. Or I also had a client and she said it got worse.
Okay. Now if it gets worse, don't do it.
Yeah.
But I think some people also somehow claim or think that meditation can replace medication. I don't think that's the case yet. So I would rather supplement it than actually replace something. But of course, if you are on a spectrum further away, you rather should do what the doctor says than you try your own stuff. Absolutely. Yeah.
Could you go back to the ER visitation data that you showed us?
Yeah.
I'm wondering if they actually measured physiological markers of health and not just
Billable encounters.
ER visitation. Is there actual physical evidence?
I think in the paper they do talk about it, but this paper was specifically designed to measure the healthcare costs. But they're still working on this data, so there may be more papers coming out where they have much more effect.
The alternative interpretation is, especially in light of the earlier data you showed us about pain processing, that these people are actually in physical pain.
But they're not suffering. That's great, actually. No, that's true. That is true. So again, that's where the how comes in. Like, how does meditation is changing their lives? That's not clear, but it's doing the good benefit that they're measuring through healthcare. Absolutely. But great question. Yeah.
Are there any studies that telomere length can be added?
Oh, actually, there's a contrary evidence, I think, if I remember right, that in certain diseases like cancer, it actually grows. So it's actually not a good thing that you add up. But as compared to meditation research, it's only slowing down. It's not the other way around yet. Yeah.
So the cortical thickness goes down with the age. Are there studies to say that thickness increase with the meditation?
No, again, the same response to the telomere. We just evidence is they're only slowing down the aging process, but not reversing the aging process yet. It was really very cool, I guess. Okay, last question, and then we should meditate. Who was? Yeah.
Are there alternative practices to meditating that are equally or similarly beneficial? For example, sometimes journaling is advanced as doing many of the same benefits, including increasing cortisol.
Yeah, great question. This question is, are there alternatives to meditating, like journaling or painting or something like that? And I love this question because it's a very key question. So if we give it an analogy, if the doctor says, go to the gym 30 minutes every day, no matter what, and I go to the gym, I take a chair with me. I sit there for 30 minutes and I come back. Perfect relaxation. I'm very happy at the end of it. And I'm not in a way saying that journaling or drawing is a bad thing. I'm just trying to say is that you're not exercising the cognitive control there. So if you take meditation from the perspective of cognitive control, the idea, at least when you're a beginner, is you're learning to exercise that cognitive control. Your attention wanders, you bring it back. But if I'm watching a TV or listening to music or doing something which I like to do, I'm not really exercising the cognitive control. I'm relaxing and I'm enjoying it. So that's a very interesting difference between relaxation and meditation, and it kind of sort of is getting blurred. Many people term relaxation and meditation and think, oh, we are doing great meditation, but in fact they're not really enhancing this aspect of cognitive control. Okay, so with that, let's meditate for 10 minutes or so. And let me just share with you very basic instructions. When step 1 of this meditation practice, this is, by the way, known as a Jyoti meditation. The idea is you see in meditation. I'll tell you what it means in a second. So the first step is you don't eat when you meditate. You don't change fragrance. You don't play any music. You keep your eyes closed. You don't touch anybody, because if they move, you move, right? Very simple first step. The second step is very interesting as compared to every other meditation practices that I've seen. In this one, the minute we close our meditation, irrespective of which practice you're meditating, we're like, okay, what do I do now? And we are so used to doing something. So 2 things can happen. One, we can just go to sleep and do sleepitation. Or we want something to do, because we are so driven by doing something all the time and we are aware. But this meditation tells us that when you close your eyes and you look in front of whatever you see, the darkness, you actually try to be aware of what you're seeing. Meaning, if you close your eyes, think of the darkness as a movie theater where the movie hasn't started yet. And it's pitch dark, and you're just focusing on whatever there is. But you're actively aware, meaning you're asking yourself, okay, what do I see now? Okay, it's darkness, maybe there's some light. What do I see now? And you're aware of what you're seeing. So you're pushing. You have a task to do, as opposed to just saying, okay, think of nothing for the next 10 minutes. Or don't think of pink elephant. It's very, very hard. In this case, you're saying, I'm actively looking at the darkness, and I'm there with the darkness, and whatever is in front of me, and then I'm aware of it. So when I get up, I can say, oh, I saw this or that, or so on and so forth. Make sense? And that's act of seeing. In Hindi is Jyoti and Shruti. Shruti means listening, and Jyoti means seeing. That's why it's Jyoti meditation kind of sort of name comes from. So don't visualize though. Don't try to think of things. Just be there with the darkness. No need to analyze it either. Whatever comes, if the light comes, or if you think there's some light, just stay there, just look at it, the center of it, and just be there. And obviously don't try to cross your eyeballs. Many people just try to focus here and then you get a headache. So if you feel any kind of pressure here, it means you're trying to cross your eyeballs. Just open them, just like you go to sleep. Just close your eyes very gently. Look about 10 inches in front of you or something. And then just stay there and be aware of what you're seeing. Because you're actively doing the act of seeing, that'll help you when your mind wanders, like, no, I need to go back to seeing. Mind wanders again, you bring it back to seeing again. And to help with the mind wandering, the other thing you can do is just repeat any word. So you can pick any word you like, peace, love, blah, blah, whatever works. Just make sure that word is not bringing memories with it. So don't say stuff like stock market or anything like that. Pick any word which doesn't bring any baggage with it. You can pick words from different languages if you like. And then every time your attention wanders, you be very kind to yourself. No need to bash. We bash ourselves plenty already in the day. For these 10 minutes, don't bash. Say, it's okay, let's come back. And be kind. And let's try this meditation for about 10 minutes. And I'm going to try to shut off the lights. Okay, well, I thought it's going to be much less people left here, but good. So I guess you like the meditation. Any comments? Any questions? How many have sleepitation? Just kidding. Yeah, go ahead.
So I start to wonder, what's the cognitive process behind sleeping?
So what's the cognitive process behind what?
Yeah, behind sleeping versus meditation.
Oh, very interesting. Usually when you're tired, when you don't have the attentional resources to actually look at it, or the task is very boring, I guess that those are the two probably. I hope I answered that. Yeah?
Thank you. Very interesting and great. I'm curious whether you've looked at questions of relaxation response and, say, those steps defining an approach to meditation vis-a-vis cognitive control. And furthermore, whether you've used the technology of the brainwave headset and both in water and out of water, warm water, to make distinctions with regard to relaxation response, possibly cognitive as
Oh, very interesting. So whether we should look at relaxation versus meditation more directly, I guess that's what the question is.
Relaxation response as meditation, redefining meditation, or defining meditation as a multiple of qualities.
And that's a good point. But the one thing just to remember that relaxation is more like an outcome of meditation, right? So if you learn to have a better cognitive control, then you can relax much more easily. And whereas relaxation, which are driven by external stimuli like music or water or some other stimulation, and that's really, you're not exercising the cognitive control anymore, right? So that's kind of sort of driven by external factors, but something to look at, absolutely. Yeah.
So like you mentioned, it can take many, many hours for you to maybe see the actual effects of meditation. And I saw in some of those graphs that even among the people who had many hours, there was some variance. And so I'm curious, out of all the studies you looked at, have people identified certain types of meditation or certain forms of meditation that are more effective than others at increasing these types of changes?
Great question. So the question is whether because it needs so many hours, is there an optimal way to get the benefit out of meditation? So another example, just another analogy to think of meditation is playing piano. So if you play the piano the first time, like you're learning, it takes hours and hours of practice. One of my piano players said he started playing at age 5. Age 35, 4 hours of play every day, that's 44,000 hours again. Now he plays beautifully. So it will take time, but some of the variations, individual variability comes from the fact that sometimes people count their sleepitation hours as meditation hours, and so on and so forth, right? So if you do it right, if you do it accurately, many studies have shown that you start seeing effects much more quicker. You don't have to wait 44,000 hours to see the effect. Perhaps a few weeks you can start seeing effects, which may not necessarily be statistically significant yet, but you can see the effect itself. In fact, my meditation teacher used to say, ask your spouse whether you're getting better.
You talked about durations. Is there an optimal duration of practice? That I believe is 41-minute meditation. You mentioned 40. I'm seeing some...
Yeah, one of the great questions is how long should you meditate? One of the papers by Sarah Lazar they were looking at roughly 40 minutes a day to show that cortical thickness experiment. The more the merrier, but the thing is when you're first learning to meditate, it takes about 10 minutes just to settle down. And if you get up at the 11th minute, you really haven't, it's like going to the gym, you just do the warm-up and you're like, okay, I'm done. Right? So you really have to push yourself a little bit. So we all have to find where our comfort zone is and whether we are really pushing ourselves a little bit or not, and then see whether that effect of pushing is actually giving you any benefits. So really very much individual. Yeah.
Is there some study on the co-habits of meditation that makes the kind of people who are likely to meditate are also maybe unconscious or more often?
Yeah, it's a great question. There are studies more with personality, that certain personality types are more prone to learning meditation or much more excited about it. Habit-wise, like diet and nutrition, I don't think there's any scientific study done yet. But many people, if you go to like Buddhist tradition, for example, they absolutely say what you eat is what you become, kind of sort of thing. So absolutely, there's definitely a correlation there, but not studied scientifically.
That briefly, there's this project here at Stanford called the Well for Life Project that is collecting data in the United States, China, and Taiwan, and Singapore that is asking behavioral lifestyle questions and meditation questions. So within the next year or two, there will be some publications on that.
Great, perfect. There you go. Yeah.
You had mentioned epigenetics as a gene expression. Can you just quickly talk about that or just point us to some research?
So there was regarding gene expression, there was a study by Richie's group again, Richie Davidson, back I think in 2003 or something, where they did the peripheral blood. They took the peripheral blood to look at how inflammatory gene expressions change, but I can give you a link afterwards, I think. Yes?
Research on different traditions of meditation and the effects.
Yeah.
New tradition.
So comparing meditations, usually people stay away from that for obvious reasons, because you can't just comparing tradition comes with its baggage, so to speak. So that's why scientists kind of take the other way around, but looking at what's the most common thing we can look at, rather than saying you're better, you're worse. I think it's easier Oh, actually, one question she asked as well is like, what's the question to that is like, what's the optimal meditation type? So the reason I like this one, I'm not again comparing the meditation we just did to any other meditation. It's like, take a meditation practice which is best suited to the goals. So if you want to enhance cognitive control, don't do guided meditations, for example, because there you actually don't exercise cognitive control as much. Do something like this. But let's say your goal is you're very stressed out and you really want a meditation technique which helps with stress first and then perhaps cognitive control, then maybe start with a meditation which is more guided, which is more soothing to begin with. So where you are and what you want from meditation, take that into account to pick up. They all do what they're supposed to do if you do it right. Yeah.
But what about your method now? This was the least preparation for meditation I've ever experienced, but 10 minutes went by like this.
That's great.
You just got us into, okay, stare in the dark, bye.
Great.
That's great.
That's great. I've been doing this since I was 13 years old. It's worked very well for me. It's called Jyoti meditation, so try it. Whatever works. Okay, thank you so much.